Objective: to determine the liquid limit and plastic limit of soil. Equipment used in this lab. Liquid limit test using Casagrande method. Take the soil and place it into the porcelain dish that the soil was previously passed through a number 40 sieve and air dried. Thoroughly mix the soil with a small amount of distilled water until it appears as a smooth uniform paste, and cover the dish with cellophane to prevent moisture from escaping. Weigh 4 of the empty moisture cans with their lids, and record the respective weights and can numbers on the data sheet and check the height of drop of the cup should rise to a height of 10 millimeters. Place a portion of the previously mixed soil into the cup of the liquid limit apparatus at the point where the cup rests on the base. Squeeze the soil down to eliminate air pockets and spread it into the cup to a depth of about 10 millimeters at its deepest point. Use the grooving tool. Carefully cut a clean straight groove down the center of the cup. The tool should remain perpendicular to the surface of the cup as groove is being made. Extreme care to prevent sliding the soil. Turn the crank of the apparatus at a rate of approximately 2 drops per second and count the number of drops it takes to make the 2 halves of the soil pat come into contact at the bottom of the groove along a distance of 13 millimeters. If the number of drops exceeds 50, then remix entire soil specimen in the porcelain dish and do not record the number of drops, otherwise record the number of drops on the data sheet. Repeat until producing successively lower numbers of drops to close the groove. One of the trials shall be for a closure requiring 25 to 35 drops, one for closure between 20 and 30 drops, and one trial for a closure requiring 15 to 25 drops. Determine the water content from each trial by using the same method used in the first laboratory. Remember to use the same balance for all weighing. Plastic limit procedure. Weigh the remaining empty moisture cans with their lids, and record the respective weights and can numbers on the data sheet. Take the remaining 1/4 of the original soil sample and add distilled water until the soil is at a consistency where it can be rolled without sticking to the hands. Form the soil into an ellipsoidal mass. Roll the mass between the palm or the fingers and the glass plate. Use sufficient pressure to roll the mass into a thread of uniform diameter by using about 90 strokes per minute. The thread shall be deformed so that its diameter reaches 3.2 millimeters, taking no more than 2 minutes. When the diameter of the thread reaches the correct diameter, break the thread into several pieces. Knead and reform the pieces into ellipsoidal masses and re-roll them. Continue this alternate rolling, gathering together, kneading and re-rolling until the thread crumbles under the pressure required for rolling and can no longer be rolled into a 3.2 mm diameter thread. Gather the portions of the crumbled thread together and place the soil into a moisture can, then cover it. If the can does not contain at least 6 grams of soil, add soil to the can from the next trial. Immediately weigh the moisture can containing the soil, record its mass, remove the lid, and place the can into the oven. Leave the moisture can in the oven for at least 16 hours. Repeat steps at least 2 more times. Determine the water content from each trial by using the same method used in the first laboratory. Remember to use the same balance for all weighing. Thank for watching.